What is this name node's responsibility? That we will see now. So basically, this name node's responsibility is what? Creating metadata for your blocks which we are storing in different data nodes. So generally when client sends some request, your data node, your name node only knows that what are all the data nodes which are having free space to store their data. So to say that this name node is just creating metadata for all your blocks which we are storing in different data nodes. Okay, so the main intention of what name node is creating metadata for those blocks. Okay, so every time, for every short period of time, every data node is sending some heartbeat and some block report for this name node, so that this name node can create some metadata for that, for those blocks from that name node, from that data node, from that data node. Okay, now see, if at any time, if this name node is not receiving any more heartbeat, then this name node can simply understand that, it simply identifies that that data node is what? Dead, if it is not receiving any more heartbeat. Okay, so simply to say, if there is no name node, there is no HDFS. Okay, so single point of failover we are calling this name node service as. This name node service is what? Single point of failover. Single point of failover. Single point of failover. If name node is going to be down, then entire cluster is what? Inaccessible. Entire HDFS is what? Inaccessible. HDFS is inaccessible. So because if name node is going to be down, definitely we are not going to have metadata. If there is no metadata, how that job tracker can contact this name node and how it is going to submit its job to what? How it is going to assign different tasks to different task trackers. So it is not at all possible. So if name node is not there, even client also cannot store data, because client is initially asking to client is initially passing some request to name node to get some details about your data nodes where you are having free space. So if there is no name node, even client also cannot access that. If there is no name node, even job tracker also cannot access that name node. So that's what we are calling this name node as what? Single point of failover service. So even job tracker also what? Single point of failover only. Okay, this is about what? The responsibility of name node in your HDFS. Okay, next, so how does this name node handles that failed data nodes? Now see, generally we are using cheap hardware, right? Commodity hardwares we are using, so there may be more failures on your data nodes. So if that data node is going to be down, we should not lose our data. For that sense, this name node is this HDFS has been given with some fault tolerance. Okay, so if this data node is going to be down, now your metadata will be changed. I mean, your name node is just trying to remove this data node from its metadata, and it is just letting some other data node should feel and should take some responsibility of having same replication in its data node. So basically this name node is just copying data from one data node to another data node. One data node cannot communicate another data node directly through name node. So they can directly communicate with one data node to another data node through some pipelining. So just say what? Here you are having two data nodes. So it is just passing that replication to same that pass. Just say what? Your file is a.txt file. So this data node is just trying to put this a.txt file into some other data node where you are having free space. So once it is done, automatically it is giving some response back to this data node to say that this a.txt file has been exactly stored. So once it is done, now again this data node is just passing some blog report for short period of time. For every periodically it is sending some blog report back to this name node. So this name node is just trying to create that metadata. It's just trying to take that metadata for that newly created block in different data node. Okay, So this is it. So each and every time this data node is just trying to send some heartbeat and some block report for that name node to say that it is alive and to say that it is having some blocks in its data node. So heartbeat will be given for every periodically. This data node is just passing some heartbeat to this name node to say that it is what working properly, okay, that it is not dead, to say that it is not dead and it is working properly. If at any time if this data node is not sending any more heartbeat for this name node, this name node is just identified that this data node is dead. So once it is done, now this name node is just trying to remove that metadata for that data node from its metadata, and it is just giving, and it is just letting some other data node should take the same responsibility of what having this same replication in some other data node. Okay, so basically here data nodes directly can talk to another data node and can give that same replication to some other data node where you are having free space, but this data node will never approach this name node to talk to another data node to give that same replication to another data node. So here basic thing is what, here every name node is receiving some heartbeat and some block report from each and every data node. So that block report means if any block is going to be stored in its data node, local data node, that block will be given back to that block report will be given back to this name node, so that this name node is just trying to create that metadata for that block for that data node. As well as for every short period of time, this data node, generally short period means it's like 10 seconds. For every 10 seconds, this data node is just trying to give some heartbeat for this name node to say that it is still alive and it is still working properly. Okay, so this is what the way how this name node is just trying to handle that failed data nodes and how to replicate that data into some other data node. So what is fault tolerance? Fault tolerance. What is fault tolerance? Basically, as we have used cheap hardwares in our HDFS, there may be a failure on your data node, or there may be a failure on what, your task tracker. So generally, sometimes your data node may be failed or your task tracker may be failed. If this data node is going to be down, are we going to lose the data or not? Just say what, you are having a.txt file in this data node. If this data node is going to be down, definitely you are going to lose what, a.txt file. If you are going to lose a.txt file, you cannot get proper output for that input file. So in that sense, this HDFS has been given with some fault tolerance. So what is this fault tolerance exactly? So even though you are going to lose this data node, you should not lose this a.txt file. So in that sense, this HDFS has been designed by giving 3 replications by default. This HDFS has been designed by giving what, 3 replications by default. HDFS has been given with 3 replications by default. So even though you are having a.txt file in data node 1, if it is going to be down, you should not lose the data. In that sense, they have given two more data nodes for taking same a.txt file. 2 more data nodes to take what, same a.txt file into their corresponding data nodes. Okay, now see, so fault tolerance has been given by that HDFS to overcome that data loss problem in your local data nodes. Even though one data node is going to be lost, 2 more data nodes are there, still they are alive and they can take care of what, and they can be submitted with same job which we are running in this data node 1. Okay, so this is what about fault tolerance in your HDFS. Okay, next question. What is speculative execution? So here you are having job tracker and what, task tracker. So job tracker is a master service, task tracker is a slave service. Job tracker is a master service and what? Task tracker is a slave service. So in HDFS, name node is a master service and its corresponding slave service is what? Data node. Job tracker is a master service and its corresponding slave service is what? Task tracker. So every task tracker is just trying to pass some heartbeat to this job tracker, as well as every data node is just trying to pass some heartbeat to data node. So this task tracker is sending some heartbeat to this job tracker for every 3 seconds. For every 3 seconds, each and every task tracker is passing some heartbeat to this job tracker. For every 3 seconds. For every 3 seconds, this task tracker is passing some heartbeat to this job tracker. At any time, if this task tracker is not passing any more heartbeat to this job tracker, it can wait up to 3 seconds of time. Up to 3 seconds of time. In that time, if it is not giving any more heartbeat, it can wait 10 heartbeats of time. It can wait 10 heartbeats of time. In that time also, if the task tracker is not giving any more heartbeat back to that job tracker can just think that that task tracker may be working very slowly, or that task tracker may be dead. So in that situation, this job tracker is just trying to pass that same task to some other task tracker, where you are having same input split, means what? Input block in different data node. So, and it is waiting. Whoever is giving output first, that will be considered. That slowly working one will be what? Stopped abnormally. So that process we are calling it as what? Speculative execution. Okay, next, what is the default replication factor? Default replication factor in HDFS. So the default replication factor is basically three replications we are giving for each and every block in different data nodes in our HDFS. Okay, so where we are setting these 3 replications? Generally we are setting these 3 replications in HDFS-site.xml. HDFS-site.xml. So we are giving some property here. So configuration property name DFS dot replication name and what? Value 1 value, and end this property tag and end this configuration tag. And end this configuration tag. Okay, so basically here we are setting the number of replications. So basically it is what? 3. So if you are working on single node mission, it is what? 1. If you are working on multi-node mission, so by default it is what? 3. So it is giving 3 replications by default, and you are setting those 3 replications in this HDFS-site.xml file. So if you wanted to make it as what? More, then you can take it as what? More. Means what? If you wanted to take it as what? 5, you can take it as what? 5. If you wanted to take it as what? Less, means what? Either 2 or 1, you can take it as what? 2 or 1. So anything you can set it up in what? HDFS-site.xml only. So these many number of replications we are generally giving in this HDFS. If your input file size is 200 MB, what if your input file size is what? 200 MB. So if its size is 200 MB, so definitely it is going to give number of 64 MB block size, number of 64 MB blocks. So why it is, sir? So basically your HDFS block size is what? By default 64 MB. By default it is what? 64 MB block size. So how many number of blocks you are going to get for this 200 MB of file? Obviously you are going to get 4 input splits. One is 64 MB, 64 MB, 64 MB, and what? Last one is what? 8 MB. So our input file, if our input file size is 200 MB, now we are going to get 4 input splits. One is what 64 MB file, another one is what 64 MB, and what this is also 64 MB, and this is what 8 MB. So each and every 64 MB block size will be stored in what? Exactly 64 MB block size of what? HDFS. Okay, 64 MB HDFS block. So this is what physical split. HDFS block size is what? HDFS block size is what? Physical split. But this input split is what? Logical split. So basically you are getting what? 8 MB only. You may be having some doubt, sir, it is what? 8 MB only. So is it occupying this 64 MB of size, or is it just occupying what? 8 MB of space from this HDFS block size as what? 64 MB. So exactly to say, if you are having 64 MB block size as what? Your HDFS block size, now it is occupying what? Just 8 MB space only in that. So remaining space will not be wasted. This will be used for some other file. So if you are go on wasting this much space, so it is taking huge amount of memory space. So obviously it is just taking what? 8 MB file only in this, 8 MB space only in this, and remaining 56 MB of space will be used for some other file. Okay, so this 8 MB is what? Logical split. This 8 MB is what? Logical split. This 64 MB of HDFS block size is what? Physical split. Okay, next. So where do we have data locality? Very important. Very important. Data locality in MapReduce. So where do we have data locality in MapReduce? So basically, what is data locality first? If you are having data local to your system only, then we can say that it is what? Data locality. So wherever you wanted to process that data, if you are having the same data in your local machine, then we can say that program is having what? Data locality. So here also, map and reduce what is a framework. It's a technique to process your data which we are storing in HDFS. Okay, so this map reduce is what? Distributed processing technique. So here map is a process which is working on the data which is local to that data node. That one we are calling it as what? Map. So generally, who is assigning this map task? Task tracker. So generally your job tracker is just trying to pass some request to, it is just trying to assign some task to task tracker, and your task tracker is just taking that request from the job tracker, and it is just trying to apply that job to the data which is local to that data node. So that process we are calling it as what? Map. Okay, so here you are having data node, here you are having task tracker. Now here you are having job tracker. Now job tracker is assigning some task to this task tracker. Now this task tracker is taking this request, and it is just giving that task to the data which is local to that data node. So just say that you are having a.txt file. So now this task tracker is applying this program on this a.txt file which is local to that data node. So this process we are calling it as what? Map. This process we are calling it as what? Map. So can we say that map is having data locality here? Because where you are running that map program, so in that data node itself we are having data. So we are saying that, we can say simply that map is having data locality. Next, but what about reducer? Reducer will never have any more data locality. Reducer will never have any more data locality. Why it is? So here you are having different data nodes. You are having different data nodes and different task trackers. Okay, you are having different data nodes and what? Different task trackers. Now this job tracker is just assigning some other task to this task tracker, and it is working on its local data node. This process we are calling it as what? Map. Again, the same job tracker is assigning some other task to this task tracker. Now this task tracker is applying that same task to this data node. So this is also what? A map. So when this reducer will come into picture, once after getting output from all your mappers, your reducer will come into picture. And it is just trying to pull data from different mappers, and it is combining all your mapper outputs in this data node. Okay, so your reducer's task is what? Your reducer is just trying to pull data from different mappers, and it is just storing them in this local file system, and it is processing that data, and finally it is keeping that data, that output in what? In that local file system itself. So here this reducer is just trying to get output of mappers from different data nodes, but it is not working local to that data node. So we are saying that this reducer is not having data locality, as it is getting what? Data from different mappers. Okay, what is the difference between CDH3, CDH4? So generally in CDH3 you are having only one name node. So very important question it is. Now CDH3 is what? Having one name node. Now CDH4 is having two name nodes. So name node 1 and name node 2. So here in CDH3, if this name node is going to be down, entire HDFS is what? Inaccessible. HDFS is inaccessible. But in CDH4, if this name node is going to be down, this name node will come into picture. If this name node is going to be down, this name node will come into picture. Simply to say, where you are having high availability of what? Name nodes. Right, now see, so as it is having only one name node, if it is going to be down, okay, entire cluster is inaccessible. But here this name node is there in some active mode, and this is what? In passive mode. This is in what? Passive mode. So two name nodes will be there in CDH4. One name node will be in active mode, another name node will be in passive mode. If that active mode name node is going to be down, this passive mode name node will come into active mode. Okay, so this name node is there in active mode, this name node 2 is there in passive mode. So if one name node is going to be down, another name node will take care of that. Okay, another name node is just come into picture, and it is just taking that failed name node's responsibility. Okay, so this is what the huge difference between CDH3 and what? CDH4. So CDH3 only one name node will be there. In CDH4 you are having two name nodes, one will be in active mode, another one will be on passive mode. So what is a heartbeat in HDFS? Heartbeat in HDFS. What is a heartbeat in HDFS? Okay, now see. So here you are having 4 services: name node, data node, job tracker, task tracker. Name node is giving some heartbeat to this data node. Data node is giving some heartbeat to this name node to say that it is what? Alive. Job tracker is receiving some heartbeat from this task tracker to say that to identify that task tracker is working or not. So task tracker is giving some heartbeat to this job tracker for every 3 seconds, as well as this data node is giving some heartbeat to this name node for every 10 seconds, almost for every 10 seconds, to say that both of them are what? Alive. Okay, so exactly to say, what is that heartbeat? It's a signal to say that they are alive and they are working properly. So if they are not sending any more heartbeat for this name node or to this job tracker or this name node is just thinking that they are dead, and they'll just replace that same responsibilities to some other name node, some other data node, as well as the job tracker is just give that same responsibility to what? Some other task tracker. Okay, so do we need to place, it's a typical question on what it is very important. So do we need to place two replications under one rack and another replication in another rack? Is it mandatory? Yes, it is absolutely mandatory. See, you are having a rack. Here also you are having what? One rack. And here also you are having another rack. So in this rack, you will be having switches. So here also you will be having some switch. Here also you will be having some switch. So each and every rack can talk to each other because of these switches. Okay, now what I am doing is I'll take some name node here and I'll take some data node here and what task tracker here. So here also I am taking some data node and what task tracker. Now here also I am taking some data node and what task tracker. Okay, now see, system number 1, 2, 3, 4, 5, 6, 7, 8, 9. So now you are having 3 racks in this. Now client is giving some data to data node 1. So by contacting this, client is contacting this name node to get some free space available in different data nodes, and once he is receiving, now this client is passing that request to data node 1 in system number 1. It is passing that request to data node in system number 1. Now it is taking a.txt file. So once it is done, this data node should give that same a.txt file replication, a.txt file to some other data node as replication. So as we have discussed, HDFS is provided with 3 replications by default. So this data node taking this client is sending a.txt file to this data node which is there in system number 1. Now this data node internally sends the same a.txt file to some other data node where you are having free space. So a.txt file will be taken. Now this a.txt file should be replicated for 3rd time. So this data node is just trying to pass this same a.txt file to some other data node in different rack, okay, and it is storing. So is it mandatory? Yes, exactly, it is what mandatory. Suppose you may be having some other doubt. So why shouldn't we take 2 replication in that rack? Why shouldn't we take 1 replication in this rack? Yes, that also is what possible. Now this data node can give same replication to some other data node which is there in some other rack. So now this data node can give that same replication either in this rack, either in this rack. So this data node must and should give the same a.txt file replication for 3rd time, either in this rack or either in this rack, but it should not be done in what? Another rack. Why it is? We will see that one. If this rack is going to be down, you are not going to lose data because you are having 2 more data nodes where you are having same a.txt file. Suppose now you got lost this rack. Now you are having 2 availabilities. If this data node is going to be down, this job tracker does not take much time to transmit that same request from this task tracker to this task tracker where you are having same a.txt file in its local data node. So in that sense, we are taking 2 replications under one rack, another replication in what? Some other rack. Okay, so this is what mandatory.